Assalamu alaikum warahmatullah. This is Muhammad Abdul Karim. In this session, I would like to describe about the marine refrigeration system. So before starting the slide, let's try to understand what is the main purpose of the refrigeration system in the onboard ship. So in the onboard ship, a refrigeration system is the magnificent part of a vessel. This is not only for the fishing vessel, cargo carrier, reefer container, as well as this system is used in the provision chamber also. Therefore, since the merchant vessel goes for the long voyage, so that is why it has to take sufficient amounts of the foods and beverage, and which has to maintain the minimum temperature. So to prevent the growth of the any microorganism, oxidization and fermentation, refrigeration system is must. And in the onboard ship, electrical engineer is the main responsible person for this auxiliary machine, obviously under the supervision of the chief engineer. If there is any malfunction or leakage, then electrical engineer has to troubleshoot it within a short period of time. Otherwise, the cargo and the provision chamber will get damaged. Okay, then let's see what is the definition of the refrigeration system. Basically, the refrigeration system is the process of the collecting or absorbing heat from any enclosed region so that this enclosed region's temperatures is getting down. In this slide, there are three objectives. At first, I will try to describe about the main components of the refrigeration plant. Then we will see the working procedures of these systems. Then we will be familiarized with the safety elements. And this is the term of the refrigeration system. Then first thing that the first thing that the element comes to our mind, that is the compressor. Compressor gets suction from the low pressure side. This low pressure, low temperatures vapor when comes to the compressor. At that time, the compressor compress its volume. Then when the discharge time, that refrigerant pressures will be high pressure and high pressure and the high temperature. We'll see the next the procedures of these systems. Okay. The next, this is the thermostatic expansion valve. Mainly, there are several types of expansion valves are there. From them, thermal expansion valve is mainly used in the ship refrigeration system. Actually, it does mainly two important jobs. First one is it expands the refrigerant so that the temperature and the pressure of the refrigerant get reduced. Then it sends required amount of the refrigerants to the evaporator. If the load inside the evaporator is increased, then it permits refrigerant flow much. Again, when the load is decreased, then it permits the refrigerant flow low. That expansion valve is also called the throttling device. Okay. Now let's try to understand what is the working procedure of the thermostatic expansion valve. This is the outlook part of the thermostatic expansion valve, and this is the symmetrical loop of this thermostatic expansion valve. This is the inlet port of the refrigerant, and that is the outlet port of the refrigerant. In between this port is the adjusting valve, or we can say it poppet valve. So by this poppet valve, we can minimize the spring pressure, and that is the thermal valve or the sensing valve. And this is uh, a thermal tube which diameter is the 1 mm. 1 mm. Okay, so let's come to this picture. We can see here a sensing valve. This is also called the thermal valve. This sensing valve is located the outer part of the evaporator. Suppose this is a evaporator, and this within this sensing valve there is a refrigerant. Suppose our refrigerant is the R22, our system's refrigerant. This R22 same refrigerant will be used in the sensing valve or thermal valve. So when evaporator is heating up from the surroundings region, that means the enclosed region, at that time it supplies the heat into the sensing bulb. When sensing bulb gets heat from the evaporator chamber, then the refrigerant which is inside the sensing bulb, that means R2D2, that will be going to boils up. As it is boils up, it creates a vapor. It discharges a vapor. This high pressure vapor when comes to here, at that instant time it creates a downwards force. When this downward force applied to the diaphragm, when this downward force applied over the diaphragm, in the meantime the diaphragm will goes down. As the diaphragm is goes down, so the path between the poppet bulb and that region will be increased. As the path is increased, at that instant time there will be much amount of the refrigerant will pass through this line. Okay, suppose when the evaporator chamber, that means evaporator outer part is getting down because our system is already cold. After that, the sensing bulb will be also cold. As the sensing bulb also cools, that means the refrigerant which is in the sensing bulb, that will also be cold. As it is cold, so after that there will be the discharge pressure will be the low. As the discharge pressure is low, then the downward force will be released. As the downward force release, then the according as per spring back pressure, the diaphragm will get up. As the diaphragm gets up, so the path between the propelled bulb and this region will be the thin. As the path is thin, so there will be the minimum amount of the refrigerant will pass through this line. So this is the overall working procedures of this thermostatic expansion valve. Let's see what is there next. Okay, this is the evaporator. Evaporator mainly a heat exchanger. Evaporator locate in the ship evaporator located the regions of the enclosed space. It gets when it gets or absorb heat from the surroundings area, at that instant time the refrigerant which is used in the evaporator inside, that will be boils up. As it is going to boils up, so when the discharge time, that will pass low pressure low temperature here, and the surroundings, I mean the enclosed region will be low, temperature will be low, because this temperature is absorbed by this refrigerant which is in the evaporator chamber. Okay, this is the suction accumulator. This is the most important part of the refrigeration system. This suction accumulator is located um, in the suction line between the compressor and the evaporator. So why this suction accumulator is used in ship? Suction accumulator system is used in ship in the refrigeration system to prevent the flood to prevent the flood of the refrigerant into the compressor. So this is the side glass. Side glass mainly used to observe or to assess the condition of the refrigerant into the pipeline. Clear side glass indicate the subcooled liquid and the bubbles indicate the saturated liquid. Then next, solenoid bulb. Okay, solenoid bulb is a electromechanical device. It works according to the getting signal from the evaporator chamber. When evaporator is heating up, at that instant time, solenoid bulb will be open. As the solenoid bulb open, so into the solenoid bulb there will be the much amount of the refrigerant will pass. Again, when the evaporator outer part evaporator is uh, cooling down, in the meantime the solenoid bulb will be closed. When the evaporator is cooling down, at that time the solenoid bulb will be closed. As the solenoid bulb is closed, then there will be the less amount of the refrigerant will pass through this line. So the main base function of this valve is to simply turn off and on the refrigerant. Okay. So what is the purpose of the filter dryers used in the refrigeration system? Filter mainly used in the refrigeration system to filterize the to filterize the any mist particle or the gas into the refrigerant, and the dryer is used to absorb the refrigerant water, and that means if in the refrigerant there is some water mist, at that instant time dryers can absorb it, because into the dryer there is used as there is used silica gel. Okay, so moisture cause two problems mainly. It can freeze the ice in the evaporator and cause blockage. It can form acid by reaction with the flame gas. Then see, okay, this is the diagram of the refrigeration system in ship. Let's try to understand what is the working procedure. Okay, let's see the working procedure of the diagram. Before starting the working procedure, this is the compressor. Let's see, this is compressor, this is the condenser, and it's the evaporator chamber, and that is the low pressure side, that is low pressure side of the system, and this is the high pressure side of the system. Okay, then suppose the compressor gets suction low pressure low temperature refrigerant. When the low pressure low temperature refrigerant comes from the evaporator, at that instant time, compressor compress its volume. Compressor compress the refrigerant volume. When the compressor reduce the refrigerant volume, and then the discharge time, the refrigerant temperature and the refrigerant pressure will be high, and it goes through the high pressure cutout. One thing remember that if the pressure exceed from the 24 bar, in the meantime, the high pressure cutout will cut off the compressor. When high pressure cutout cut off the compressor, I mean strips the compressor, in the time between, we have to come here to reset the high pressure cutout. Otherwise, the compressor will not run automatically. Okay. So high pressure, and suppose our system is okay, our pressure is less than 24 bar. So the high pressure and high temperature liquid will go through the line. We can also check the temperature of the refrigerant by the thermometer. Then the high pressure, high temperature liquid comes to the condenser. In the condenser, in ship, mainly shell and tube type condenser is mainly used, and the compressor will be a reciprocating compressor. And according to the refrigerant plant, that will be the single stage or multi stage. Okay, when the compressor comes to the condenser, we condense this refrigerant, high pressure high temperature refrigerant, by the seawater. But in the system do not take suction the seawater from the sea chest directly, because we cannot use the seawater directly. We have to purify it by the freshwater generator, because we have to maintain the 1 mm, oh, sorry, 1 parts per million, 1 ppm, the salinity of the seawater. Then this by this seawater we condense our refrigerant. Okay. Okay, when the refrigerant is condensed by the seawater, then it will the high pressure but low temperature refrigerant will comes to the receiver. The and it can reserve in the receiver. If there is any maintenance within this portion, we can store the refrigerant, and the upper side of the refrigerant there is the air Bangkok. So by this air Bangkok we can out the air if our systems has any kinds of air, the refrigerant. And there is the drain valve. So from this drain valve, our refrigerants will come down from the by the through the solenoid valve, and it will go to the dryer stipon glass. Okay, let's try to understand why master solenoid valve is used in that system. Actually, master solenoid valve gets a signal from the motor control. If there is any cutout, either it is a low pressure cutout or high pressure cutout, in the mean at that time, motor control device or motor controller will pass a signal to the master solenoid valve to block the system. As it is block the system, then there will be no refrigerant flow will be go through the master solenoid valve. Okay, suppose our system is okay, there is no low pressure cutout, low pressure and high pressure, so the refrigerants will go through this line from the within the filter and dryer. Already said, filterize if the refrigerant has any mist or oil particle, and dryer will be absorbed if the systems or refrigerant has any water particle. So the siphon glass, we can observe the condition of the refrigerant. So, and the refrigerant will go to the solenoid valve and then thermostatic expansion valve to the evaporator. Here you see as sensing valve. This sensing valve assess the condition of the evaporator. If, if the evaporator temperature is high, then it passes a signal to the thermostatic expansion valve to open the solenoid valve. As the solenoid valve open, then much amount of the refrigerant will go through this line. And when the evaporator temperature is false, at that instant time, thermostatic switch will block the solenoid valve. Okay. So why this thermostatic expansion valve is used? Thermostatic expansion valve is used because into the thermostatic expansion valve, when high pressure, low temperature refrigerant go, and then discharge time, it convert that high pressure, low temperature refrigerant to the low pressure, low temperature refrigerant. If you just have a look in this picture, suppose when the high pressure, low temperature liquid compressed air, refrigerant will expand. At that instant time, it reduces its temperature and pressure also. It lost its temperature and pressure also. This low pressure, low temperature refrigerant, when go to the evaporator, at that instant time, it will absorb the heat from the surroundings area. That means the enclosed region. When it getting the heat from the enclosed region, then the enclosed regions temperatures, the enclosed regions will be cooled down, and the refrigeration which is inside the evaporator will be boils up. As it is boils up, then discharge time, the refrigerant will be converted to the vapor form. Then the low pressure, low temperature vapor will go to the compressor. Okay, here you see the low pressure control, I means the low pressure cutout. So why we use this low pressure cutout? Yes, this low pressure cutout is as like as the safety device of the compressor, as like as the safety device of the high pressure cutout, and both is a safeguard of the compressor. Okay, when the in the low pressure cutout, there is a low pressure controller. This low pressure controller continuously assess the condition of the suction line from the which is comes from the evaporator. When the suction line pressure, listen, when the suction line pressure is lower, then then that means the evaporator is cooling down. As the evaporator is cooling down, that means our room or enclosed region is properly cooled. Then it cut off the compressor. It cut off the compressor. Again, when the suction pressure is increased, in the meantime, it it start the compressor because at suction pressure increasing means the evaporator or the enclosed region's pressures is temperature is getting too high. Okay, here in the right side view, there we see the defrost element. Why this defrost element is used in the refrigeration plant? As you see, the evaporator is located into the enclosed region. So it has a chance to cover or accumulated the ice into the evaporator chamber. If the evaporator is accumulated by ice, then there will be the problem to thermal exchange or heat exchange. So in the certain period after in the certain period time interval, we have to start the heater to melt the ice over the evaporator. Okay. Let's see another simplified view of the refrigeration plant. Here we see almost all elements which is there in the previous slide, but there are some other elements. Here we see the oil pressure switch newly and the oil separator. Why oil pressure switch is used? Oil pressure switch measure the sum pressure of the refrigerant and the suction pressure. If the sum pressure and suction pressure plus minus 1.5 bar, at that instant time it will cut off the it will trips the compressor. Okay, again, this is a high pressure cutout, this is the low pressure cutout. There we see an oil separator. Why oil separator is used? If from the compressor chamber, if any oil particles comes to the refrigerant, at that instant time the oil separator separate these oils and go to these oils, pass this oil to the compressor again. Then the refrigerants will go to the condenser and it is condensed by seawater. Then we can reserve it to the reservoir. Here we see a liquid line side glass. Okay, the side glass. From this, by the side glass we can see the condition of the refrigerant. Here is a charging connection. Why this charging connection is used? If our system's refrigerant is getting low at the or there is any leakage, in that meantime we can charge this refrigerant through this line. There is a filter diode and this is a bypass valve. Okay, when we use this bypass valve, if there is any maintenance, then we can use this bypass valve. Suppose everything okay, then our refrigerants will come through this line. And in the ship, there are three compartments of the refrigeration plant. The first one is the meat room, vegetables room, and handling room of the fishing room. Meat room temperature shall be keep into the minus 15 degree, to minus 70 degree Celsius, and the pressure will be almost 1.6 bar, 1.6 bar, 1.6 bar. And the the vegetables room temperature will be keep in minus plus 4 degree to minus minus 5 degree Celsius, and the temperature the pressure will be around 3.6 bar, 3.6 bar. Okay, the fish room temperature is like as the meat room temperature, minus 15 degree to minus 17 degree Celsius, and the pressure will be 1.6 bar. Okay, here we see the back pressure valve. Why this back pressure valve is used in this refrigeration plant? So what is the purpose of the using the back pressure valve? This back pressure valve is mainly used to ensure that the pressure into the refrigerant which is in the evaporator, it never falls down the set below. Okay, here we see the heating coil. This is a heating coil, and that is the heating coil. That is also a heating coil. So heating coil we use to defrost uh, the chamber of the evaporator, as it is located into the enclosed region. So it will be iced in the after time interval. So it needs to be heating up so that the ice can be melt. Okay, I already described about the low pressure cutout and the high pressure cutout. Let's go through. This is a compressor safety. Low pressure cutout is the compressor safety which cut off the compressor in the event of the pressure drop in the suction line. The pressure of the suction line is continuously sensed by the control unit, low pressure control unit. When it goes below the set value, that means the room is properly cooled, the low pressure cutout will auto trip the compressor, as I already said. Then the high pressure cutout. High pressure cutout activates the trips the compressor when discharge side pressure increase the above the limit value. What was the limit value? The limit value was 24 bar. If its exceed discharge side pressure exceeds the 24 bar, at that instant time, it just trips the compressor. The reason, the high pressure, okay, the high pressure cutout is not auto reset, okay, it's not auto reset, and it has to be done manually. Why? The reason behind it is to manually attend the fault which is leading to rise in the pressure, else this situation can lead to overloading of compressor parts and may damage. Okay, thank you to all. In this, I prepared this slide from the Marine Auxiliary Machinery by SD McGeorge. In our next session, I will try to describe about the single line diagram of the refrigeration plant in the onboard ship. Thank you to all.